Hi, this is the 2023 for MB number 12. So, and then 12B number 6. Okay. So we are looking for the roots of this polynomial. Okay. So that there is like 10 binomials, and the roots of these polynomials are removed from the real number line. What remains is a union of 11 disjoint open interval. On of those 11 disjoint intervals, how many of those will be positive? Okay, so the question actually really nice because it's asking to like know some of the key features of the polynomial, which is, I'm not sure if you know about this, but the key point right here is basically asking us to remember the even multiplicities are gonna just bounces back from the zeros. Okay, so what I mean by basically, like if you were to have like let me just remind that real quick. So like if you were asked to graph a like quadratic in most simple cases, okay, so and if I have this, and if I want to have a graph of this basic graph, so you will have something like this. So the zeros of this polynomial or this quadratic, if you make it is equal to 0, the zeros of this quadratic is just 0, which is this point. So, but look at what's going on. You know, from the left side of the 0, so you were getting closer to 0 when you like from the higher values all the way to the like y equals 0. But after y, like I mean, yeah, y value was 0 when your x value is getting closer to 0 from the left side. And if you increase the x values to the right, so your y values increasing, which means the any points on this graph doesn't have any point on the other side of the x-axis, which is on every point on the same side. If you were to have this like fourth power, it will be similar to this graph, but it will be slightly changed, but the shape will be still like U shape, okay? But this is telling us like when you have the even power of any polynomial, then you are not gonna cross the x-axis. You are not gonna cross the solution. You are not gonna cross the zeros. You are not gonna cross the roots of the like polynomial. You are gonna just touch x-axis and go back. That's basically what you wanna remember. And then we call this a multiplicity. So if your multiplicity of the polynomial is like at some point is even, that means you are not going to cross the x-axis. You're going to touch it and go back to the in the same I guess area, like in the same positive or negative region. Okay, so I hope that is something we do know. If not, this was a kind of review. Let's put those points on the number line. Okay, so if I were to start with like 1, like 2, like 3, 4, 5, 6, 7, 8, 9, and 10. So it will continue this way, right? So the first thing we have to ask to ourselves about the problem, like we need to know the signs, right? So there is something we call like sign diagram, so it might be useful. So if you were to draw that, so let me actually make it a bit better looking. So we start with some the roots, and we list the roots from the least to largest to see all different intervals. Okay, and then I'm gonna call this is P of X. So if you were to choose a number that is 1 lesser than 1, you know, this guy will be a negative value. So any power of like multiple of 2 is like any even exponent will be always positive. So this was negative, this is positive, and this will be negative because if you choose like negative 2, the inside is negative, any odd power of the negative is still negative. So it will continue plus and negative all the way to the positive. Since we have 10 terms, the 5 is negative, 5 is positive. So if you multiply 5 negatives, you will get negative, which means whenever you choose x is lesser than 1, your polynomial, let's say this is 1, is going to be negative right here, okay? But after you get 1, okay, so when you choose anything between 1 to 2, let's say 1.5, The first one is gonna be positive, okay? But this is gonna be still positive because that doesn't change since the power is even. I mean, since the power is even, so you will get always positive, and then this is gonna be negative, and then you will continue positive. But make sure that you see the first the root, like first binomial, I would say, is a positive instead of negative in our second interval. So in this region, since 1 to 2, we will make this binomial positive number. So the number of like negatives like actually decreased by 1. So we have now 5 negatives in total. So if you multiply 5 negatives, you will get a positive number. And then you could have just said this immediately because when you are actually passing a root, if that has odd multiplicity, which is 1, x equals 1 has odd multiplicity of 1, which is why you're going to change the sign because you're going to cross the x-axis and then you are going to go in the other direction. So which is why the sign will change. And you may just continue these sign changes and number of evens, I mean, number of like negatives and negative positives. You could go with it for the every single number, but you don't really need it because after you realize when you have the even multiplicities, you are not going to cross the x-axis. You're going to have the same sign as before. So this was positive, this is going to be positive. And then at 3, it's odd multiplicity because x minus 3 has a third power. So which is why it will change the direction. It will move on to the other side of the x-axis. So at 4, okay, so it will not change the side. It will be still on the negative version because this is even multiplicity. So you will get a negative. And if you do this for the remaining, so I guess you know what's gonna happen. So this is gonna be 8, 9, and 10. So at 5, it will change the sign. At 6, it will not. At 7, it will. 8 will not. So it shouldn't be. Okay, and then 9 will, and then 10 will not. So if you look at the number of like region, like we are told if you are removing the roots, like we have now 11 intervals, like one of them is like negative infinity. Okay, so let me write this better. All the way to the positive 1. This is one of these 11 intervals. And the second interval is 1 to 2. And 1 and 2 is not included. And 2 to 3. If you keep doing this all the way to the last one, so you will get 9 to 10 and 10 to positive infinity. These are my intervals, right? So of those 11 intervals, if you see that, like we have one positive right here, 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 one positive right here. So total, we have 6 of those intervals that has a positive value. So which is why your polynomial will be positive in those 6 different intervals. Okay, so the question if didn't like really ask to remove those zeros, like if we were to look at the like the positive values of the polynomial without removing the zeros, the answer might be changing, which is I'm gonna leave that for you as a challenge to think about it and see if you have any choices gonna be the answer if that was the case. Okay, but that was so we are asked to remove the solution. So we just have to hide those different intervals, which is 6 of them. So I'll see you in the next video.